And this integral is not as simple as I thought it was. It's quite rather complicated. So let me carefully work out. I call this integral I, and I create another integral which is j from 0 to half pi sine x plus cosine x times cosine x dx. All right. Then I plus j is obvious that you have a common factor, and the numerator will be cancel out denominator, so it's equal to x dx. So that integral is easy, pi square over 8. So this is my I plus j. Now, j minus I is not that simple. This will be equal to from 0 to half pi. This x, the common factor will be x, right? Cosine x minus sine x dx, and sine x plus cosine x. Yeah, this one is equal to 0 to half pi, and x, this is sine x plus cosine x, and on top it becomes the derivative of sine x plus cosine x. This derivative is cosine. This derivative is negative sine. Perfect. So altogether is a derivative log function. So this one is equal to integral from 0 to half pi x d log sine x plus cosine x. Yeah. Good. So once I write things like this, I can use by parts, the u dv. Right? So this one is equal to uv, u times v from 0 to half pi minus v du, the integral. So this one is natural log sine x sine x plus cosine x, right? dx. Okay, excuse me for little messy writing. This is a 1. This is 0. This is the 0. This is a 1. This is 0. This is 0. So everything's 0. And the minus integral from this. Now here, for this integral, the sine x plus a quarter pi will be equal to sine x times cosine quarter pi, which is 1 over root 2, plus sine quarter pi is 1 over root 2 times cosine x. So we have a common factor times this over there. So that means root 2 times sine x plus quarter pi is equal to sine x plus cosine x. So here I have a sine x plus cosine x. I can replace it by that. See? So this one is equal to log root 2 times sine x plus quarter pi dx. Yeah, very good. Mm. Then I can separate the logs. This becomes a negative, so half pi, and log root 2 dx for the first one. And for the second one is a log sine x plus quarter pi dx. Good. Now, this one is easy. Negative half pi log root 2. For that one, I can split from 0 to quarter pi. I can do two parts. That is, from 0 to quarter pi log sine x plus quarter pi dx, and this another part from quarter pi to half pi log sine x plus quarter pi dx. Right? I split this one into two. So from 0 to quarter pi, from quarter pi to half pi is this. And I call this one is I1, this is I2. Okay. I1, this is I1. Huh? Let me write this is I1, this is I2. Excuse me, this is rather informal writings. But anyhow, this is I1, this is I2. I1 is equal to negative natural log sine x plus quarter pi dx. I can use a substitution. Let t be x plus quarter pi. Then this becomes a log sine t, isn't it? Dx and dt is the same thing, dt. When x is 0 is a quarter pi. When x is a quarter pi is half pi. So this is my I1. Now I2 is this, negative, huh? From quarter pi to half pi, natural log sine x plus quarter pi dx. So okay, this is I2, and we have a formula from a to b. F of x dx is equal to, from a to b, f of a plus b minus x. Well, if you haven't seen it, you can prove it easily by substitution. Let x be a plus b minus t, right? You get this one. Well, anyhow, I leave the proof for you. This is a useful property when you do some integration. So this one is equal to negative is a negative here, minus quarter pi plus to half pi, quarter pi to half pi, natural log. I use this for, okay. This is sine quarter pi plus half pi minus x plus quarter pi and dx. I simply use this property, okay? And this one is equal to negative quarter pi to half pi. Quarter pi, half pi, quarter pi is a pi. Natural log sine pi minus x dx. Well, we know that sine pi minus x is equal to sine x. So this one is equal to, and there's no room for it, from quarter pi to half pi natural log sine x dx. Well, this is I2. This is I1. They are same. They are same. Well, except t and x, right? Just dummy variable. So I get my j minus I. Ji minus I is a negative pi over 2 log root 2 minus I1 and I2 are the same, is equal to 2 integral from quarter pi to half pi log sine x dx. Okay, I hope you can follow. All right. Then this one is equal to log 2 is a half log root 2 is a half log 2. So this is equal to negative quarter pi log 2. For this one, for this integral, I can write it from 0 to half pi log sine x dx minus from 0 to quarter pi log sine x dx, right? Yeah, this minus this is this. From 0 to half pi minus from 0 to quarter pi becomes from quarter pi to half pi. Yeah. So this one is equal to negative quarter pi log 2 minus 2. Now, I have two videos. One is for that. The other one is for this. And this one is equal to half pi log 2. That is this one. Minus, for this one is a negative quarter pi log 2 minus half of g. This integral is this. This integral is that. See, the details are in my two videos. The linkage is below. If you want to see the details, and you can go see my videos. Okay, the linkage is below. And g is a constant. G, well, let me write this simplification first. So this one is equal to quarter pi log 2 minus g. After simplification, yeah, g is this. G is the from 0 to infinity, negative 1 to the power of n, 2n plus 1 square. That's called Catalan. Catalan's constant is the summation of a infinite series of a reciprocal odd number square. Okay, that is the. But anyhow, you can see the details in my previous videos. And then we are looking for I, right? We are looking for I. I is equal to 1/2 I plus j plus minus rather j minus I. Right? So this is 1/2. This is pi square over 8 minus this and plus g. So it's end up with pi square over 16 and my pi over 8 log 2 plus half g. That is my integral for this one. And you can work out for j, right? Well, I'll leave it for yourself. That is pi square over 16 plus pi over 8 log 2 minus half g. Okay, that is for this integral. Okay, g is this Catalan's constant. And for these integrals, please go see my videos. The linkage is below. This is not very simple integrals, but it's a very good, very good practice for improving your techniques of integrations. I hope you can see all these details, including the 2 more videos for these two. And I hope you like it. Thank you.